What we have here is this, guys. During a trigonometry lesson, a group of students made some predictions about what they expected to find for the values of the trigonometric functions of some angles. Then they found the sine, cosine, and tangent of 25 and 50. In the table below, correct the 3 decimal places, the values they found. Okay, so we just gotta put in some numbers. Ready? So, can somebody tell me what sine 25 is? Make sure it says D. Sine 25? 0.42. Good man, Aaron. So, 0.42? Ah, I see. Ah. So, sine 25 is what again? Do the 2 decimal places. Give me the right answers. So 0.423. What do you get for sine 50? Okay, cos 25. 98. 0.906. Sorry, I couldn't hear the thing. Cos 50. Louder, please. 643. Yeah. Next one. Yeah. And 1.192. Okay. Maria said the value from any of these trigonometric functions will always be less than 1. Was Maria correct? No. Why? Tan 50 is bigger than 1. Or tan 50 equals 1.192. Okay. Sharon said if the size of the angle is doubled, then the value of the function will also double. True or false? False, because is sine 50 twice as big as sine 25? False, as sine 50 is not twice as big as sine 25. Everybody alright with that? Okay, next part after that. James said from the value of all these trigonometric functions will increase if the size of the angle increases. True or false? Why'd you say false, Ben? Well done. Cos 50 is bigger than cos 25. You can see the values above. So therefore this is false. Was James correct? No, he wasn't correct. Give a reason for your answer, because cos 50 is bigger than cos 25. Alright. Is that the next question? What's sine 25? 0.4. 4226, yeah. After that, Ben, and louder. Yeah. Yeah. And tan 40. 8391. Everybody get them? Okay. B, this one. The angle BP is shown in the triangle below. On the diagram, clearly label the side opposite P. What side is opposite P? That one there, yeah? Clearly label the one that's adjacent. Okay. If the length of the hypotenuse is, if the length of the opposite is 9 and the length of the adjacent is 12, find the length of the hypotenuse. How do you find the length of the hypotenuse, guys? Pythagoras' theorem. X squared equals the smaller two squared and added together. So what are the smaller two? 12 and 9. Put that into your calculator, and what does that say x squared is going to be equal to? 225. How do I find out what x is? Square root 225. 15. How many of you got that last night? Oh, good. What happened? Okay. Now, this one here. Ella is building a house in Montreal. The roof of the house must have a minimum slope. Just to allow rain and snow slide off the roof more easily. So look, there's some rain or snow. What you want to be able to do is for this to be able to slide off the edge of the roof. Is that alright? It's pretty slick. Now, what we have next is the pitch of Ella's roof is 6 in 12. The diagram shows below shows her house and marks the angle B. So basically, our full question revolves around what do you think? What if I just told you that's the full question, pretty much? Despite all that right and all the misdirection, that's all we're looking at. It's that yellow part. Do you see it?
Good afternoon, sorry for the last intrusion.
Okay guys, so write down, using the right angle triangle ABC, write down the value of tan. Anybody remember what tan is again? Anybody know the rhyme? Toa, okay? And it's broken up into three different parts. Sine, cos, and then I need a different colour here. That one, it's a weird colour. Tan. Okay, which one do we want to use? Tan. It tells you use tan. So tan is equal to what? Toa. Oa. O and A. Opposite over adjacent. Which is a half. Write it as a fraction. Yes sir. Alright. Calculate the measure of angle B. How do you find out what this angle is? There's a special button that does it for you. Anybody remember the button? Okay. First of all, let's take a bit of ownership regards to the answer. Let's see if we can predict. We can just do this in a test, can't we? Now you can't write down the answer, but you can say, look, it looks around 30 degrees to us, doesn't it? Yeah? Around 30 degrees would be a good answer. Everybody agrees with that? Okay. So now that we know around 30 degrees might be a good answer, here's what we're going to do. We're going to tan inverse of what Barry told me to do. So tan inverse a half, Barry, and what you get? That's pretty good, isn't it? Nearest degree, it was meant to be close to 30. As it turns out, it's 27. That's good enough. It's roughly what we're expecting. Okay. Find the length of the roof from A to B. Anybody want to tell me how to get A to B? We already have two sides, don't we? Pythagoras' theorem. What are the two lengths you know, Wushin? So 6 up and 12 across, call that x. So what's Pythagoras' theorem then? Oh yeah, I'm using x, work away, yeah. 6 squared plus 12 squared, x squared will equal 180 square root that. Screw around 180 and you get 13.42. Well done. Excellent. Is it meters or centimeters? Meters. Okay. Now, Yasmin wants to find, are you looking? Wants to find the height of her house. She measures the angle of elevation from the top of the roof using a clinometer. The angle is 30 degrees. She is standing 18 meters from the point on the ground directly below the apex roof. Yasmin draws the diagram above to show this information. Use Yasmin's measurements to find x. Our whole question is located where at the moment? Well, that's a bit weird. Let's try this again. Just there, isn't it? The triangle. Now, With this triangle, what two sides do we know? We know the adjacent, and what are we looking for? Okay, O and A. Which one are you going to choose? You're going to choose tan, aren't you? Tan of what angle? What angle is the tan? Tan 30? It's always the angle that goes beside the tan. And what does that equal? Opposite over adjacent, which is x over 18. There we go. X over 18, not too bad. Now, just get rid of that intermediate one and bring it in there. Now, what can we do to both sides? What can we do to get the x on its own? Goal of the question is x is on its own. So what happens to the 18? It's division on the right hand side of the equals, which makes it multiplication on the other side. So what's 18 tan 30? Anybody get it? $10.39. That's a good question. Yes, Kenny. To one decimal place, thank you. So 10.4. What is it? Meters, is it? Meters. Okay, good. Now, what other information is needed to find the height of the house? So we're trying to find the height of the house, yeah? And that's where we're at the moment. Now, what height do we know? We know here to here. What are we missing out on? Here to here. So we're missing out on her height there, aren't we? If we were to grab her like this, that's a bit bigger, isn't it? Scaled her up a little bit too much. That's her there, yeah? It's her height. It's her eye height, isn't it? So she took the measurement, obviously, from the measurement. If you were to look at her head here, if we zoomed in on her head, that angle would be going from her eyes outwards. Do you get what I'm saying? So we need to find. We need to know the girl's height. What's her name? Oh, Jasmine. Okay. So we need to know Jasmine's. I spelled Jasmine wrong, right? Jasmine's height. Okay, everybody right with that? Is there anything else? That's it. Okay, now, next one. Anne wanted to create a question box, a question which would use sign 22 in its solution. She drew a diagram and wrote the question below. Find the height of the kite above the ground. Anne has not enough information to answer a question. Put in an appropriate measurement to complete it for her. This is an interesting question now. Good one to pay attention to, I might say. Sometimes you have to put in your own measurements. So, can somebody tell me a good measurement, a good length for a kite? How far would a kite be away from you usually? Sorry? Now, yeah, something like 10 meters is grand. Now, you can do this two ways. You could say, look, the length of the string is 10 meters, couldn't you? That's a good idea, isn't it? You could measure the length of the string pretty quickly. And what it wants you to do is it wants you to find how high it's above the ground. This is what we're looking for. Height h, yeah? Now, using this function here, what do we have? We have the hypotenuse and we're looking for the opposite. Using your measurement, find the height in the diagram. You could have a different answer that works perfectly, by the way. You could do this several different ways, okay? So what about this? It's going to be sine 22 equals, remember opposite and hypotenuse? You're using so. Okay? We're using so. So Ryan, what's a sine equal? Yeah. Opposite over hypotenuse. So, and then the other ones are ka, and the last one is toa. We're using the hypotenuse, which is 10, and the oddly enough the opposite, which is labelled h. So what is the opposite again, guys? Opposite is labelled h, and the hypotenuse is labelled 10. How do we get h on its own? 10 sine 22. And what is 10 sine 22? Did you do that, Ben? You just got it there, did you? 3.75 maybe? Yeah. Did anybody else do a different way that they want me to check out? Anybody else attempt it a different way? Mathsisfun.com. Now, this one's interesting, alright? Boat A travels due north from, a boat travels due north. It starts here, yeah? And it goes it goes for 30 minutes at 20 kilometers an hour. Do you travel the full 20 kilometers? Why not? Because you're not traveling for an hour, are you? You're traveling for half an hour. So how much distance do you cover when you travel? You're only going to travel 10 kilometers, aren't you? That's using distance equals speed multiplied by time, and half an hour would be 0.5 multiplied by 20, which in turn gives us 10. Then, amazingly, we stop at point B because it's such an amazing question and all the rest. Alright, riveting. Now, we then turn around for some god unknown reason, and we're trying to get away from something. And then, for 24 minutes, we travelled at 10 kilometers an hour. Now, this one's more difficult, because this time the speed is worth 10, but it's not half an hour, is it? So it's a more awkward number. So any idea what number fraction I could use there? 24 divided by 60. 24 divided by 60, because look, 24 divided by 60 tells you that it's just under a half an hour, isn't it? So it'll be just underneath 0.5. Would everybody agree with that? So 0.4, that sounds about right, doesn't it? 0.4 multiplied by 10. We only go 4 kilometers this time. We didn't get far enough, I'm afraid. Now, and then we're at this point C. How many kilometers has the boat travelled? 10 plus 4 equals 14. By the way, you'd actually have to show what workings would you have to show? You have to show what I did up here. Yeah, I'd say so, yeah. Now, next part after that. On the diagram, show a line segment that gives you the shortest distance back. We're on water, aren't we? Yep. It's trigonometry. 9 times out of 10, pretty much every time we're going to use a what? A right angled triangle. That's really good. What about the next part, guys? Use Pythagoras' theorem to calculate the shortest distance. What is the shortest distance back? That right there, yeah? So how would you calculate that? Equals? Yeah. Which equals? 100. X squared equals? And then the answer? You square root it. X squared means what number do you multiply by itself to get? Somebody make me a rough estimate? Where do you think that should be? What number when you multiply it by itself gives you 100 as an example? It should be a number bigger than 10 then, shouldn't it? 10.77. Good enough. The nearest meter? 11 meters. Oh, sorry, 11. Wait a second. That's a trick question, because it's in kilometers. So they're being sly. Okay? So, sly. Now, what we get here is 0, 3. I'm going to keep all the decimals for a minute. See this here? That's 10 kilometers. So I'm going to multiply it by 1,000 to turn it into meters. 10,770 meters. That was a trick question, guys. Or 10.7703 kilometers.